So we're talking about Pythagorean theorem and its converse. And the Pythagorean theorem itself says if you're dealing with a right triangle and the legs of the right triangle are A and B with the hypotenuse being C, then if we were to square the two legs, A squared plus B squared, they should be equal to C squared. Okay. You should be familiar with this a little bit from previous classes at this point. But we're going to use this theorem in the converse to make sure that sides that we have do indeed form a right triangle. We're going to talk about Pythagorean triples. Your answers for these, when you solve for one of those sides, should be in the simplest radical form. So simplifying those radicals is still going to be necessary in this chapter. But then we can also use the converse to see, if a triangle, if three sides of a triangle do fit into the formula, that would mean you're definitely dealing with a right triangle. Okay. So we have a few things that we're going to talk about. Okay, the first thing you need to be aware of, and it makes your work a little bit shorter, is Pythagorean triples. Okay, a Pythagorean triple is a set of whole numbers A, B, and C that satisfy the Pythagorean theorem. Okay. One of the triples that people are more likely to remember would be 3, 4, and 5. If you plug in 3 and 4 as your legs, because those are the two shorter lengths, you do 3 squared plus 4 squared, it does equal 5 squared. The nice thing is if you recognize multiples of those, for instance, if I double each of these, 6, 8, and 10 is a Pythagorean triple because it's just twice as big as each side. Okay, so it would still work. So if you recognize those three together or a multiple of those three, for instance, if I know my sides are 3 and 4, I don't have to plug them into the theorem to know that my hypotenuse is 5, right? A couple other pairs, or not pairs, but a couple other triples would be 5, 12, and 13. 8, 15, and 17. 7, 24, and 25. To be honest, the one that I remember is the 3, 4, 5. I forget about some of the others. I know that 12 and 13 are involved in the in this triple, but then I always forget what goes, what the third number is. So I would say your most useful one is going to be 3, 4, and 5. That'll save you some time in different circumstances. Okay, one of the things you're going to be doing is checking lengths of sides to see if they fit into a Pythagorean triple, okay? Or to find a missing side. So the first thing we're going to do is find the hypotenuse. So if we have side lengths of 20 and 21, and we want the hypotenuse, We're going to call this C. Now I know the theorem says a squared plus b squared equals c squared, and they do that because we think A, B, and C, they go alphabetically, but this is going to be more useful to you with what we're doing with some of this if you start with c squared, okay? Because a lot of times, I mean, if you're solving for c squared, then it's on the left for you already, and we're going to be actually using inequalities to see if it's not a right triangle, if it's obtuse or acute. So I'm going to suggest that you put c squared first. So we have c squared equals 20 squared plus 21 squared. So c squared equals 400 plus 441. C squared equals 841. And what is the step that you would use when you're trying to find just C? Take the square roots. And you're going to check your calculator and see if that is a perfect square. If it's a whole number, it is. So in this case, it is 29. If you take the square root and it is not a perfect square, you're going to have to simplify the radical, okay? But at least check it first. It'll save you the time, you know, going through finding prime factors. So the hypotenuse should be 29 units in this case. Okay, now you might not have a diagram to use. Maybe they just give you some information. So if they tell you you have a hypotenuse of 25 and a leg of 10, and they want you to find the other leg, you could draw it out, but what do you need to know? I mean, you don't have to. What's important in this information? What's the piece that needs to be by itself? 25, the longest, the hypotenuse, or the longest length. So we would say 25 squared equals 10 squared plus, doesn't matter in this case if you call it A or B, but plus B squared, just to make sure every piece is squared. Okay, so we've got 25 squared is 625 equals 100 plus B squared. Now what do? Subtract 100. So I've got 525 equals B squared. Take the square roots. And unfortunately, 525 is not a perfect square. So you're going to have to simplify it. So we have 5 and 105, and that would be 5 and 21, and 21 would be 3 and 7. Okay, so in my radical, I've got 5, 5, 3, and 7. My 5's come out. So this would be 5 radical 21 for my missing leg.